Welcome, my friends! This will be a foundational video in your study of trigonometry, and will cover something you may already be familiar with from geometry, which are the trigonometric ratios. Trigonometric ratios relate to right triangles, that is, triangles that have one right angle. Here is an example of a right triangle, with the right angle of 90 degrees indicated by the little square. To work with a trigonometric ratio, we need to choose one of the two angles that is not the right angle. Let's choose this one. Traditionally, in trigonometry, an unknown angle is represented by the Greek letter theta, which looks kind of like a zero with a line through it. Once we have chosen an angle theta, we can identify the other sides of the triangle with relation to that angle, and we have special names for them. You may already be familiar with the term hypotenuse, which refers to the side that is opposite to the right angle. Here is the right angle, so the side opposite to it is over here, which I will label as h for hypotenuse. The side opposite of theta is over here, and we label this as the opposite side, or O. The only remaining side we label with an A for adjacent. The term adjacent is conventional, but is a little bit misleading. With respect to theta, there are actually two sides that are adjacent, but one of those two sides is the hypotenuse. Traditionally, the side we label as adjacent is the side adjacent to theta that is not the hypotenuse. Note that we could have chosen the other non-right angle to be theta, and if that was the case, we would have this picture, with the opposite and adjacent sides switched around. The hypotenuse is the same, no matter which angle you've chosen to work with. Okay, now that we have chosen an angle theta to work with, and have identified the sides of our triangle, we are now ready to introduce the trigonometric ratios. A trigonometric ratio relates one of the acute angles of a right triangle to the ratio of two sides. By acute angle, I just mean one of the two angles that are not the right angle, which will both be less than 90 degrees, making them acute. Sine is our first trigonometric ratio, and sine of theta is equal to the ratio of the opposite side to the hypotenuse. Next, we have cosine. Cosine of theta is equal to the ratio of the adjacent side to the hypotenuse. Finally, we have tangent, and tangent of theta is equal to the ratio of the opposite side to the adjacent side. You must memorize these ratios if you don't have them memorized already. It is essential to your success in trigonometry. Sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. Luckily, mathematical geniuses who have come before us have created an easy-to-remember mnemonic for the three primary trigonometric ratios, which is SOHCAHTOA. So relates to sine and says that the sine of an angle is equal to the opposite side divided by the hypotenuse. Ka relates to cosine and says that the cosine of an angle is equal to the adjacent side over the hypotenuse. TOA relates to tangent and says that the tangent of an angle is equal to the opposite side over the adjacent side. Now, these are the three primary trigonometric ratios, but there are three additional trigonometric ratios that are based on these three ratios, which are what we call the reciprocal trig functions. We have cosecant, which is the reciprocal of sine, secant, which is the reciprocal of cosine, and cotangent, which is the reciprocal of tangent. By reciprocal, I just mean that the ratios are flipped. Sine is opposite over hypotenuse, so the reciprocal function of cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse, so the reciprocal function of secant is hypotenuse over adjacent. Tangent is opposite over adjacent, so the reciprocal function of cotangent is adjacent over opposite. The most common mistake that students make is thinking that sine and secant are reciprocals, or that cosine and cosecant are reciprocals. It's tempting to think that that might be the case because sine and secant both start with s, and cosine and cosecant both start with c, but that just isn't correct. Sine goes with cosecant, and cosine goes with secant. Let's find the six trigonometric ratios with respect to the angle x in this triangle. As I said a moment ago, traditionally, an angle is represented by theta, but sometimes you might see an angle represented by x, as we see here. With respect to x, E is the opposite side, D is the hypotenuse, and F is the adjacent side. Sine of x relates the opposite side to the hypotenuse, so sine of x is E over D. Cosine of x relates the adjacent side to the hypotenuse, so cosine of x is f over d. Tangent of x relates the opposite side to the adjacent side, so the tangent of x is e over f. If you already have solved for the three primary trig functions, you can simply reciprocate them to find the reciprocal trig functions. Cosecant is the reciprocal of sine, which is d over e. Secant is the reciprocal of cosine, which is d over f. Cotangent is the reciprocal of tangent, which is f over e. You could also use the formulas directly to find cosecant, secant, and cotangent, but it's very important that you memorize which of the three primary trig functions each reciprocal function is related to. Give this one a shot. Assume that the capital letters relate to each of the angles of the triangle. See if you can find the 6 trigonometric ratios related to the angle L. Pause the video and see if you can write down all 6 of the ratios. Okay, with respect to L, 7 is the opposite side, 25 is the hypotenuse, and 24 is the adjacent side. Sine of L is opposite over hypotenuse, which is 7 over 25. Cosine of L is adjacent over hypotenuse, which is 24 over 25. Tangent of L is opposite over adjacent, which is 7 over 24. The reciprocal functions are cosecant of L, which is the reciprocal of sine, or 25 over 7, secant of L, which is the reciprocal of cosine, or 25 over 24, and cotangent of L, which is the reciprocal of tangent, or 24 over 7. There's one more thing that I want to mention about the trigonometric ratios, and that is to emphasize that they truly are ratios, and for any given angle, the ratios will be the same, even if the side lengths of the triangle change. To help explain what I mean, consider this triangle. In this situation, we know one of the angles is 53.13 degrees, and we also know all of the side lengths. Let's just focus on cosine for a moment. Cosine of our angle of 53.13 degrees is adjacent over hypotenuse, which is 3 over 5, or 0.6. What does cosine of 53.13 equaling 0.6 really mean? What it doesn't mean is that the adjacent side must be 3 and the hypotenuse must be 5, so that when we divide them we get 0.6. Sure, that is true in this case, but in general, if you have an angle of 53.13 degrees, that does not mean that the adjacent and the hypotenuse side have to be 3 and 5. 0.6 is just the ratio of the adjacent side to the hypotenuse side. That's why we call them trigonometric ratios. There are actually an infinite number of triangles that could be constructed that have a ratio of the adjacent to the hypotenuse side of 0.6, and all of them have an angle of 53.13 degrees. Here is another triangle that also has a ratio of the adjacent to the hypotenuse of 0.6. 6 divided by 10 is 0.6. Any right triangle that has an angle of 53.13 degrees will always have a ratio of the adjacent to the hypotenuse side of 0.6, no matter what the side lengths are. Another way to think about this is that if the angle is 53.13 degrees, the adjacent side will be about 60% of the length of the hypotenuse. You should get in the habit of thinking about trigonometric ratios as ratios, and not simply as SOHCAHTOA, as that will really help you later. Here's another triangle where we don't know the side lengths, but we do know that one of the angles is 30 degrees. We can't actually solve for the side lengths, but what we can figure out is the ratios between one side length to another if we use a calculator with the trigonometric ratio functions. If we type in sine of 30, we will get out 0.5. Note that if you are not getting 0.5, it could be the case that your calculator is set to radians rather than degrees, so you may need to toggle a setting. What does sine of 30 equaling 0.5 really mean? Remember that sine of an angle is opposite over hypotenuse. That means that the opposite side must be half of the hypotenuse. This is just a ratio, so we don't know what the side lengths are for sure, but what we do know is that for any right triangle that has an angle of 30 degrees, the opposite side will be half of the hypotenuse. For example, maybe the opposite side is 1, and the hypotenuse is 2. That would be consistent with the opposite side being half of the hypotenuse. Or maybe the opposite side is 5, and the hypotenuse is 10. That would also be consistent with a ratio of 1/2. If the angle is 30 degrees, the ratio of the opposite to the hypotenuse must be 1/2. How about cosine? Well, if we type in cosine of 30 into our calculator, we'll get about 0.8660. Cosine is adjacent over hypotenuse, so this means that the ratio of the adjacent side to the hypotenuse is about 0.866. If I stick with the picture that I already have here, I can take my hypotenuse of 10 and multiply it by 0.866 to find the adjacent side of 8.66. I really want to emphasize that this is only one possible triangle that satisfies our trigonometric ratios. I could scale this triangle up or down to create a similar triangle that would also satisfy the ratios. The main point of this example is to emphasize what the trigonometric ratios really are: ratios. All they tell us is that, given an angle of a right triangle, the ratio between any two sides will be the same, even if you scale up or down the triangle. I encourage you to experiment and find tangent of 30 degrees on your calculator, which will give you the ratio of the opposite to the adjacent side. You should be able to confirm that with the picture that we've created based on our sine and cosine, the ratio for tangent will also be true. Alright my friends, that wraps up my video introducing the trigonometric ratios. Join me in the next video as I explore how to solve a right triangle using the trigonometric ratios as well as the Pythagorean theorem.